Hi, in today's lesson, we're going to learn about alkenes and alkynes. That's compounds containing carbon that have double and triple bonds. Here we go. So that is our title, Unit 5, Section 2. So we did spend a couple of days previous on Section 1. You guys learned about alkanes, which were singly bonded straight chains or rings. And we got the same deal here today with these types of compounds. So let's start by talking about some alkenes. Okay. An alkenes are carbon chains that have, I'm going to put at least one double bond, at least one double bond. We're only going to look at alkenes that have one double bond. We're not going to get into multiple ones. So alkenes are carbon chains that have at least one double bond. So carbon can form a double bond with another carbon. Now, when it comes to our simplest one, we cannot have an alkene that only has one carbon. We need to at least have two carbons. So if I were going to draw one with two carbons, here's what I would do. I would draw a carbon here, I'd write a double bond, and I'd write another carbon there. So that represents my double bond. Now we're used to always making sure that carbon has 4 bonds, and that hasn't changed. But the number of hydrogens we're putting on these carbons now has changed because each of these carbons, so this carbon here, already has 2 bonds. So when I go to draw the hydrogens, I'm only going to be able to draw one there and one there. And I drew them at an angle. You don't really need to worry about drawing them at an angle. But if we were to take the molecule kits and actually do it, they would come out looking like an angle. But the point is that each of these carbons can only contain 2 more hydrogens. So every carbon has 4 bonds. You don't believe me? Let me count them. 1, 2, 3, 4. And same thing for the other carbon. Now, our name. Because we have 2 carbons, we're going to use F as our beginning prefix. And our ending is now changed. Because it has a double bond, this E is going to represent double bonds. So by writing ethene, I'm showing that we got a compound that has a double bond in it. So that is your simplest alkene, ethene. So let's kind of build our way up here a little bit. The next simplest one would have 3 carbons. So here is how I would write that. I would take my carbon and I'd make a chain of 3 carbons. I'm going to put that double bond right here. And that's going to represent our, I guess, second simplest alkene. And again, our goal is to write in all the hydrogens. So this carbon here already has 2 bonds, so I'm going to put it with 2 hydrogens. The carbon in the middle has 3 bonds. It's got one there, and one there. It's got 3 bonds to it, so we're going to write 1 hydrogen in. Doesn't matter if you put it pointing up or down. I'll put this one pointing there. And again, if you want to write H3 as a condensed, that's fine. We could condense any of these ones. Maybe just for consistency, though, I will write this one out in full with the hydrogens pointing up, down, and to this way. Again, if you want to condense it, that's fine. Condense them. Okay, so 3 carbons. That represents, or we use prop to represent 3 carbons. Because there's a double bond right there, we have to reflect that in our name by putting an E here. Propene. And that is our alkene with 3 carbons. Hopefully easy enough, straightforward. Again, if we had the molecule kits and we were in class, that would be helpful. It would be especially helpful for the next one because something weird starts to happen when we get to 4 carbons. So let's do this. 4 carbons. There's my 4 carbons. And I'm going to put a double bond right there. Now, if we were in class, I would ask you guys to make this with your molecule kits, and inevitably, most of you would make this carbon, or this carbon chain. This is this example. But believe it or not, a few of you would actually make a slightly different one. That slightly different one begins looking like this, but what ends up happening is some kids create it with a double bond in the middle spot. And hopefully just by looking at those two, you can tell that those are different molecules. The double bond is in different spots. Like you could physically hold it and it would be held in a different position. So we've got a little something extra happening here. Now, before we proceed though, I'm going to complete this by writing in all of my hydrogens. These ones in the middle each need one, like that. Now we are going to need, it's a little addition to our naming conventions here for things with multi-bonds. That's what I call a double or triple bond. I call them a multi-bond. So both of these carbon chains have 4. So both of these names are going to be butene. This is a butene, and this is a butene. But of course, we need a little bit of extra information to indicate where that multi-bond is. Where is it located on the chain? So one thing we've gotten used to, I hope, is counting how many carbons we've got in our chain and then numbering them. And we kind of do that as well, except there's a little caveat for this. What we want to do is we want to number our carbon chain so that the multi-bond is in the lowest position possible. So what I mean by that, and I'm not numbering the carbon chain here. What I'm numbering is the positions in between. So I'm actually going to call this my first spot, that's my second spot, and that's my third spot there. So by putting a 1-butene here, I'm telling the reader that the multi-bond is in the very first position. Now, if we had other stuff on this chain, we would then also number our carbon chain, and then we'd see where that is. But this always sort of trumps it. You always want the multi-bond to have the lowest number possible. Now, when it comes to our next carbon chain here, that's a 1, that's a 2, and that's a 3. So we have our multi-bond in the 2 spot now. This is a 2-butene. Now, I guess the question becomes, could we have a 3-butene? Well, I don't know. Let's see here. So let's say I gave an example, and I said, draw 3-butene. Okay, so you'd say, okay, butene is 4 carbons. I'm going to put that multi-bond in the 3rd spot here. And then I'm going to put in my hydrogens. Like that. And you might be pretty proud with yourself right now saying, yay, I did 3-butene, because you numbered it left to right. 1, 2, 3. Does anyone see a problem with what I've done here? Well, I hope you do, because I've really kind of numbered my chain backwards. I've numbered it incorrectly. If I want to have the lowest number possible, it doesn't matter which way I number it. I could have numbered this as 1, 2, and 3. So technically, the numbering system I did in red would have been wrong. This is a 1-butene. This question is wrong. You cannot have 3-butene. It doesn't exist. 3-butene is the same as 1-butene. They are the same compound, just flipped over. So you got to be careful with that. That multi-bond can maybe go in a couple of different spots, but it can't go in every spot. Now, we made an important discovery here too, and I'm going to flip back to that previous slide for a second, because this one was sort of incorrect, right? Okay, so back to this one. I think it was the first lesson we talked about structural isomers. Those are compounds that have the same formula but are drawn differently. And in a way, these are structural isomers as well. But if you flip it, it could be 1. You're right, Marie, it's always in the 1 spot for the butene. So these are the 2 versions of butene you get. Now, so these are structural isomers, but they're actually a second type of isomer. These are called positional isomers. I don't really have a lot of space to write this. Positional isomers. I'm going to write an official definition on our next slide. to me, this one's actually pretty easy. It's a easier version, and I think it's easier than structural isomers. There's not a lot of thinking you got to do with this one. And I'll write the definition on the next slide here. But again, positional isomers, the multi-bond's in a different position on the carbon chain. So let's write that in here. Okay, so positional isomers. Compounds where the multi-bond is in a different spot on the carbon chain. I'll give you a sec to write this down. So multi-bond is like your key word here. So this is actually the second type of isomer we've come across. We came across structural isomers. Now I've come across positional isomers. And there's a third one we're going to be learning in a future lesson called geometric isomers. So there's going to be 3 types of isomers. Now, it's probably easiest if we just do a little question with this one and sort of figure it out. So what if I gave you this here? So, example, draw and name all the positional isomers of hexene. Yeah, hexene, that has 6 carbons. That's C6, H, I think it's H12. H14 would be the alkane version. And we're just taking off 2 hydrogens and you get your alkene version. I think I've done that right. Okay, so why don't I give you just a couple of minutes here to start. I mean, your first move is just to draw 6 carbons. And a little tip here, kids, I think they get overexcited when they come to a question like this because this is the question where kids most often forget to draw the hydrogens in afterwards. They just draw the carbon chains, they name it, and they forget to put all the hydrogens in. So if there were 3 answers, I might give 1 mark for a drawing and 1 mark for a name. So if there were 3 answers, that'd be like out of 6. But then inevitably, I got to take off a few marks because you've missed the hydrogen. So give that a moment here. Okay. So if I was going to answer this 1, 2, 3, 4, 5, 6, I'd say there's my first one. And again, I'll go back and put those hydrogens. 1, 2, 3, 4, 5, 6. Okay, now I'm going to put it in that spot, but maybe I can name these as I go along. So this would be a 1-hexene. This would be a 2-hexene. Now, I think I can get a 3-hexene here. Which I can, 3-hexene, but I can't get a 4 or a 5, because if I got a 4, if I wanted to write 4-hexene, that would just end up being 2-hexene flipped over. And if I wanted to say there was 5-hexene, that would just end up being that one flipped over as well. So there should be that many answers. So now kind of the annoying task of writing in all the hydrogens. It's a little tedious, but again, we got to do it. Did it. Okay, so 3 answers. So a question like that on a test, I'd have that out of 6 marks. I give 1 for drawing, 1 for naming. And if you did come up with extra answers that were incorrect, I'd probably take a few marks off. If you didn't do the hydrogens, I'd take a few marks off as well. So there we go. So that's pretty much all I have to say about these straight chained alkanes. But we do have to add some substituent groups to these, to some of these. Okay? And so let's just talk about naming alkenes. So again, most of our rules from earlier apply. There's sort of just one kind of beginning rule. Rules for naming alkenes. So before, our rule was, when it was an alkane, was you find the longest chain and you name it, and then you number so your numbers for the subgroups are as low as possible. But there's a little exception. Maybe this makes it a little easier. So we want to number the longest chain, so the multibond has the lowest number possible. And that's it. You just kind of stop. You don't then go back and renumber for the subgroups. You just do it once. So I guess there's probably some situations here where you could end up with maybe a really long chain that doesn't even have the multibond in it. And so that's fine. And then, like I said, the rest of the rules just all sort of repeat. You know, I don't even know if we need to write the next one here, but it's number 2 is number the chain. Don't renumber, but number the chain to identify the locations of the subgroups. So if you've got the multibond on one side of your question and the subgroups on the other end of your question, the first one, this is what takes precedent, okay? And maybe that's even like the first example we can do here. So let's do that. Let's name the following. I think drawing is always easier. Naming is always a little more difficult. So let's try a couple of examples here. I don't really want to do a ton of them because they're a little repetitive. Name the following. Megan, does hexane have 14 hydrogens? Hexane has 14. Sorry, I missed a couple of questions there. So hexane has 14, but hexene only has 12 because we've taken 2 away to make a double bond. And Kylie, wait, you said don't write down the 2. What was that for? Don't write down the 2. Was that back for this question here? Sorry, sometimes it's hard. If you guys type your questions, I tend to miss them. Oh, the rules. Okay, so yeah, so when we did for the rules here, so number the chain to identify the locations of the subgroup. One thing I left out for this number 2 here was I didn't say number the chain so that the subgroups get the lowest number possible. We're not worried about that with our multibonds. I think actually that'll become maybe a little more. Here, let me do this example, and I think it'll become obvious what I'm talking about here. So let's do one with that, and I'll put the multibond there, and then I'm going to I'll put this pointing up here. Let's put a couple of methyl groups. Let's have one of them here and here. Okay, so let's try those. I'll write the hydrogens in a second. Okay, so we want the longest chain that contains the multibond. And we have a couple of options, and I think it's probably just easy enough for us just to go straight across here. Okay, so that would be 6 in a row. So 6 is hex. We need an E next to represent that this hex has a double bond in it, so hexene. And we're also going to number our chain. Hopefully it's pretty obvious here that it's in the 1 spot. I am just going to number the rest of these bonds. So this is a 1 hexene. Now we do have to worry about those substituent groups. So, and here's where maybe a little confusion can occur. We're not going to renumber our chain so that those subgroups get the lowest number possible, because they are at this end of the molecule. If that double bond right there, we'd say, yeah, that one's in the 2 spot, one's in the 3 spot, but we're not going to renumber. So back to old school here, where we number the carbon chain. This is actually, this carbon is our first carbon. This is our second carbon. This is our third carbon. So we've got something on the 4th carbon here, and then that's our 5th carbon. We've got we got 1 methyl group on the 4th and 1 on the 5th carbon. So again, we don't really care that these subgroups have a high number. Our rule is that this multibond has the lowest number possible. So to complete this one, we've got a 4,5 dimethyl. Now just be careful when you get to this point that you put an extra dash there, because again, we always separate words and numbers. Okay, so that's about it. Really, that's the only thing we kind of have to worry about. All the other examples are really kind of similar. There's only one kind of exception, and that's when we get a ring with a multibond in it. So why don't we tackle one of those? Really, I think one example is probably enough for us to get this, because again, they're all pretty repetitive here. If you can do this one, every other one should be similar. But what can happen is we can get a multi-bond on a ring. And this gets to be a little more tricky. I'll draw one for you. So I've got a cyclopentane here. And when you put the double bond in, you actually put it like, say, there. So with this one now, again, our rule always says that we want to get our multi-bond in the lowest spot possible. The thing about this ring is that we can name any carbon or any spot as our first carbon, meaning that this multi-bond is always in the first spot. So we don't actually need a number to indicate where it is. But what we do need is a name here. So I would just call this one cyclohexene. I kind of don't need to write the 1 in. I used to write the 1s in a lot, but then I realized that that multi-bond is always in the 1 spot. It's kind of redundant. It has to be in the 1 spot. It couldn't be in the 2 spot. Because again, our rule says you always want the multi-bond to have the lowest number possible. Okay, so, oops. So that one is just cyclohexene. Again, I've got an E there, and that tells me that we have a double bond. So the only way this could be a little more complicated is if we added some stuff onto it. So let's do one more example with a ring and a double bond. Like that. Let's put our double bond right there. And then let's just put a couple of groups here. Let's have a C3H7, that's a prop group. And I don't know, C4H9. So we're going to have kind of a long name here. So what kind of shape do we have here? It's 6, so we have a hexane, but it's got a double bond. So we have a hexene, and since it's a ring, technically it is a cyclohexene. Okay, cyclohexene. I did a bad job of the most important letter in that word, which is this one here. That's an E. So cyclohexene. Now again, it's understood that this is a 1-cyclohexene. We don't need to write the 1 in. We do need to understand that this is the first bonding spot. So now, one thing we do need to consider is that we can get these subgroups to have a lower number, kind of depending on which way we name it. Because here's what we know. We know that this is either carbon 1 and that one's carbon 2, or vice versa. It all depends on where the stuff is. So, again, like I was saying, this could be carbon 1 and this could be carbon 2. It all depends here. I think this way that I'm going right now would give us a wrong answer, right? Because that would be 3, that would be the 4th, that would be the 5. We'd have 2 things on the 6th spot there. I think it makes much more sense if we just number it the original way I had it. And that way, uh-oh, it's going to crash on me, isn't it? I'm good, still there. I may have to erase, let's see. Yeah, okay, so this green numbers I put, they're not going to end up being right. And again, hopefully you see that if we actually make this the 1 and this the 2, then we have 2 groups on the 3rd carbon there. Obviously 3 is lower than 6. So this is one of the situations where we had 2 options. We had that straight chain example earlier when we only had 1 option. Now we've got a couple of options. So this is a prop and this is a butyl. Butyl comes first. So 3 butyl dash 3 propyl. Oh man, I kind of ran out of space there. And then there wouldn't be a dash there, yeah. So that worked out nicely. So 3 butyl dash 3 propyl cyclohexene. And I'm going to put that all as one word because there's no number in between. So I wouldn't put a dash there. So that covers everything with a double bond. But that's only half the story. Oh man. We just spent a half hour going over all this stuff and we realized that, well, wait a minute. We also got triple bonds to talk about. The good news is that the double and the triple bond stuff, everything's exactly the same. The only difference is that we're not using the letter E now to represent a double bond. We're going to use a Y to represent a triple bond. So we can probably fly through the second part as long as you understood the first part. We've got an alkyne. These have a triple bond. Again, you need at least 2 carbons to have a triple bond, don't you? So we can't have a triple bond with just 1 carbon. We need to have 2 carbons. So if I was going to draw the simplest one, I'd draw it like that. And each of these carbons can hold 1 hydrogen. It's like our general formula would just be CHCH. So we're probably used to having an alkane and knowing that CH3 represents an alkane. As soon as we removed a couple of hydrogens, that means we have a multibond. So again, this is I just wrote this as the general formula. That's that condensed. I probably should have done that earlier. And our name is eth representing 2 carbons, and a Y tells us there's a triple bond. We don't need a number here because there's nothing to number. We don't say 1 ethyne. The multibond can only be in that first position. And like kind of all the other stuff sort of plays out as well. If we were going to do the next one here with a triple bond, it actually wouldn't matter where we put that triple bond, because if you flipped it over, it would still be in the first position. You do have to be careful about your hydrogens. That middle carbon doesn't actually need any hydrogens because it has 4 bonds. 3 for propyne. Once you get to the bute, though, you can actually, again, have a couple of different answers. So when we hit the 4 carbon chains, we now need to number it so that our compounds have the lowest possible. Hopefully I'm not doing too fast through this part here, but it's all repetitive. It's all things we've done. So if we have 4 carbons, you could have one answer like that. Or you could have one answer like that. So this would be a 1-butyne, and this would be a 2-butyne. There's no 3-butyne. Again, don't forget those hydrogens. I always debate whether or not I want to write them in, but I should. Again, notice those 2 middle carbons don't end up getting any hydrogens because they already have 4 bonds. And then even when it comes to our examples here, if we have a straight chain one, again, we just want a number so that our chain gets the lowest number possible. It's all kind of the same things, right? Let's see if I can come up with a good one though here. We'll do 2 more examples and we'll wrap it up. So let's say, I'm trying to think of a good one here. Let's say we do that. We put the triple bond here, and we do that. 1, 2, let's go 1 more. I kind of wish I'd started that up a little bit higher. I didn't mean to bend it there, but that's how it went. Yeah, this one almost kind of worked how I wanted it to go. So again, your first thought when you look at this one is, oh, we just want to draw this straight across. That may or may not end up being the right answer. It's actually not the right answer, because if you're looking for longest chains, you can actually get a longest chain. Oh, I think it's going to crash again. You can get a longest chain with actually 3 carbons in it. 3 carbons, I mean 6 carbons in it. Where are we here? Ah, oh, man, my example. I'll have to redraw it. Oh, that's a bummer. How did it go now? Let's see, I had 1, 2, 3, 4, 5. I had the triple bond there. What do I have? 3 carbons going down. Bear with me. So I guess we could actually have 6 carbons in a row if we go across and down. If we did that, we'd have 1, 2, 3, 4, 5, 6 carbons. I should actually made that a little bit longer. So that's a 6 carbon chain. The problem is that it doesn't have the multi-bond. So that one we just drew is incorrect. You know what? I'm now finding that if I put highlighter on something and it crashes when I try to get rid of the highlighter. Okay, I'll redraw this one for, again, the umpteenth time here. I'll have to edit this out for future use. I won't, though. So again, just to redraw this one for the 3rd and final time here. Okay, this one looked like this. Now, I was thinking that I wanted to have a longest chain that didn't have the multi-bond, but I guess we can actually have a carbon chain of 6 that has the multi-bond if we actually went down this way, right? So we have 1, 2, 3, 4, 5. We have 6 carbons here. So if we number a chain, that's the first spot, that's the second. We really only care about the first spot, I guess, right? Because we would call this one a 1 hex ine. The Y represents the triple bond. And we have a subgroup over here. I know I left the hydrogens off. What carbon is this off? Well, that would be our first carbon. That would be our second carbon. That would be our 3rd carbon. So this should be an ethyl group off the 3rd carbon. So 3-ethyl-1 hexine. And yeah, so sorry about all the crashing there. So again, just make sure you get your longest chain that has the multi-bond. And then the last one I'll show you, and I'll keep this one simple, would be, what do we have? How does it look when we have a triple bond for a cyclo compound? So let's just draw this one here. And the triple bond, you actually get the bond inside and one outside. So this would be a cyclobutene. I don't need a number because, again, that multi-bond is in the 1 spot. Cyclobutene. I don't go anywhere. I've stopped.